Here we are going to talk about differentials. Well, we know this that dy by dx is equal to f dash x, which you can also find out using limit of delta x tends to 0, f of x plus delta x minus f of x upon delta x. Well, you know this that f dash x, this dy by dx, is nothing but the slope of fx differential dy is given by f dash x dx. You can also remember it using this, that dy by dx is equal to f dash x, so dy is equal to f dash x dx. Now you have y is equal to fx. When x is going to change to delta x, okay, when x changes by delta x, it will also lead to change in y. There will be some change in y, which we say as delta y. Now this difference coefficient oh, I'm so sorry, I told you coefficient. Difference coefficient is delta y by delta x, which is nothing but rate of change of y with respect to rate of change in x. Now, if delta x and delta y, they are infinitesimally small. In case of delta y and delta x, both of them, they are very small, infinitesimally small, then in that case delta y by delta x could be written as dy by dx. So on the one hand, you can write delta y as delta y by delta x. You can write this delta y by delta x into delta x. You can write delta y as this. But in case if this is very, very small, so this can be written as dy equals to dy by dx dx. dy by dx are called differentials of x and y respectively. These are called differentials of x and y respectively. Derivative, let me just give you one geometrical interpretation for this. Suppose you have I'm so sorry. Suppose you have this. It is x and here it is y. And the function given is, this is say y is equal to fx function. Okay. Now at some x naught, this is the value of the function a. Now x naught changes by say this much amount. I can just put it with red, you'll be able to see it better. So how much y naught changes by? It changes by this much. So in case if you look at it, this is the change in x and this is the change in y. If you take the tangent at A, how will that look like? That look like something this. This is the tangent at this point A. Let us name these points. This is say B, B and C. Okay. This entire change BC is the change in y, which is delta y, and the entire change AC is delta x. Okay. So for a given change in x, which is delta x, which is AC, the true change in y is BC. This is your delta C. Now, in case if we are using the slope of the line, okay, in case if we are using the slope of the line AB, if this is the line, okay, how should I draw this for you? Say this is the line AB. If we are using slope of the line, what is the slope of the line AB? Slope of the line is given by delta y by delta x, which is equal to BC by AC as the relevant rate of change. Okay, suppose if this is the relevant rate of change, because this is the actual rate of change, and we applied this to this equation which we had here. So in that case, which is delta y is equal to delta y by delta x into delta x, which is delta y is equal to delta y by delta x into delta x, then it should have been basically BC over AC into AC. But we note that we are not using delta y by delta x. We're not using delta y by delta x. Instead, we are using dy by dx. Now, since we are using dy by dx in lieu of delta y by delta x, the slope of the tangent line, AD, okay, since we are using dy by dx, the slope of the tangent line or slope of AD is going to be used instead of slope of the line AB in calculation. So what is the slope of the line AD? Which is CD upon AC. So we are not using delta y by delta x into delta x. We're using dy as dy by dx into dx, which is CD by AC into AC. So the change is basically when you are using dy by dx, the change is given by CD. In reality, change is given by BC. Okay, now CD differs from true change BC. And what is the error? Error is given by BD. Error is of course given by BD. Now, in case if delta x is small, the error is also going to be small. And the process of finding the differential dy, the way you have found out this dy, this process is called differentiation. This process is called differentiation. Let me give you one example here. Suppose y is equal to x square plus 3x plus 2. Suppose this is the real function which you have. Then what is dy by dx for this? 2x plus 3. So you can write dy equals to 2x plus 3 into dx. Now say x changes from 2 to 2.01. So what is delta x? Delta x is 2.01 minus 2, which is 0.01. What is dy? Dy is 2x, okay, which is 2 into 2 plus 3 into dx, which is 0.01, which is 2 into 2, 4, 4 plus 3, 7, 7 into 0.01, which is 0.07. But in reality, x is equal to 2. Okay, initially x is equal to 2. So what is the value of the function at x equals to 2? 2 square plus 3 into 2 plus 2, which will come out to be 12. When x actually goes to 2.01, what is the value of the function? Y equals to 2.01 square plus 3 into 2.01 plus 2, which will be 12.0701. Actually, new y is 12.0701 and delta y is 0.0701. But what we have found as dy is 0.070. Okay, so how much is the error? Error is 0.0001. This much is the error, and this is an approximation here. Okay, so here error is arising.